National Electrical Code Article 70 addresses equipment intended for general use. This section of the code provides requirements and guidelines for the installation and use of various electrical equipment to ensure safety and proper functionality. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It is updated every 3 years to reflect changes in technology and best practices. Article 70 is just one part of this comprehensive document. Understanding the scope and application of Article 70 is crucial for electrical contractors, installers, and anyone working with electrical systems. This article covers a broad range of electrical equipment, including but not limited to luminaires, appliances, motors, transformers, and control devices. It is essential to consult the latest edition of the National Electrical Code for the most current and accurate information. Firstly, NEC 70.1 covers the general requirements for equipment. This includes the listing and labeling of equipment. Equipment must be listed by a recognized testing laboratory to ensure it meets safety standards. The listing mark indicates that the equipment has been tested and certified for its intended use. Secondly, NEC 70.2 addresses the installation of equipment. This includes requirements for mounting, support, and protection from physical damage. Equipment must be installed in a manner that prevents it from becoming a hazard. This may involve using appropriate enclosures, raceways, and supports. Thirdly, NEC 70.3 deals with the wiring of equipment. This includes requirements for conductor size, insulation type, and termination methods. Conductors must be sized appropriately for the load they will carry, and they must be protected from overcurrent. Fourthly, NEC 70.4 covers the grounding of equipment. This includes requirements for grounding electrode conductors, equipment grounding conductors, and bonding. Grounding is essential for preventing electrical shock and ensuring the proper operation of overcurrent protection devices. Fifthly, NEC 70.5 addresses the overcurrent protection of equipment. This includes requirements for fuses, circuit breakers, and other overcurrent protective devices. Overcurrent protection devices must be sized appropriately to protect equipment from damage due to overloads or short circuits. Sixthly, NEC 70.6 deals with the control of equipment. This includes requirements for switches, disconnects, and other control devices. Controlled devices must be readily accessible and capable of safely disconnecting equipment from its power source. Seventhly, NEC 70.7 covers the marking of equipment. This includes requirements for nameplates, labels, and other markings. Equipment must be marked with its voltage, current, power rating, and other pertinent information. Eighthly, NEC 70.8 addresses the maintenance of equipment. This includes requirements for periodic inspection, testing, and cleaning. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical equipment. Ninthly, NEC 70.9 covers specific types of equipment such as luminaires, appliances, and motors. These sections provide additional requirements that are specific to each type of equipment. Tenthly, NEC 70.10 deals with hazardous locations. This includes requirements for equipment installed in areas where flammable gases, vapors, or dust may be present. Equipment installed in hazardous locations must be specifically designed and approved for their use. The National Electrical Code provides specific tables and examples to aid in the proper application of its requirements. These resources can be invaluable for understanding and complying with the code. Furthermore, it's important to note that the National Electrical Code is not a design manual. It provides minimum safety requirements, but it does not prescribe how to design an electrical system. Electrical engineers and designers must use their professional judgment to ensure that electrical systems are safe and reliable. The National Electrical Code is a living document that is constantly evolving to reflect changes in technology and best practices. It is essential to stay up to date with the latest edition of the code to ensure that electrical installations are safe and compliant. Understanding the basic principles of electricity is crucial for working with electrical equipment. This includes understanding voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. Power is equal to voltage multiplied by current, or watts equals volts times amps. These basic principles are essential for understanding how electrical equipment works and how to safely install and maintain it. Safety is paramount when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses. Never work on live circuits unless you are properly trained and equipped. If you are not comfortable working with electricity, consult a qualified electrician. Electrical work can be dangerous, and it is essential to take precautions to protect yourself and others. The National Electrical Code is a valuable resource for ensuring the safe and proper installation and use of electrical equipment. By understanding the requirements of Article 70 and other relevant sections of the Code, you can help to prevent electrical hazards and ensure the reliability of electrical systems. Additionally, remember that local codes and regulations may also apply. It is essential to check with your local authorities to determine the specific requirements in your area. The National Electrical Code is a minimum standard, and local codes may be more stringent. Compliance with all applicable codes and regulations is essential for ensuring the safety and legality of electrical installations. In summary, NEC 70 provides essential guidelines for the safe and proper installation and use of electrical equipment. It covers a wide range of topics including listing and labeling, installation, wiring, grounding, overcurrent protection, control, marking, and maintenance. By understanding and complying with the requirements of Article 70, you can help to prevent electrical hazards and ensure the reliability of electrical systems. Always consult the latest edition of the National Electrical Code and local codes and regulations for the most current and accurate information. Electrical safety is everyone's responsibility, and it is essential to take precautions to protect yourself and others from electrical hazards. Remember to always de-energize circuits before working on them, use appropriate personal protective equipment, and consult a qualified electrician if you are not comfortable working with electricity. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific electrical projects and installations. Furthermore, it is important to understand the difference between branch circuits, feeders, and services. A branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or equipment. A feeder is the circuit conductors between the service equipment and the branch circuit overcurrent device. A service is the conductors and equipment for delivering electric power from the serving utility to the wiring system of the premises served. Each of these components has specific requirements in the National Electrical Code. For example, the size of the conductors in a branch circuit must be adequate to carry the load served by the circuit. The overcurrent device must be sized to protect the conductors from overcurrent. Feeders must be sized to carry the total load served by the branch circuits they supply. Service conductors must be sized to carry the entire load of the premises. Proper coordination of overcurrent protection is also essential. Overcurrent devices must be coordinated to ensure that the smallest overcurrent device closest to the fault opens first, minimizing the impact on the rest of the electrical system. This is typically achieved through selective coordination studies. The National Electrical Code also addresses the requirements for various types of wiring methods such as rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable. Each wiring method has specific requirements for installation, support, and protection. Choice of wiring method depends on the application and the environmental conditions. For example, rigid metal conduit is often used in corrosive environments, while non-metallic sheath cable is commonly used in residential wiring. The National Electrical Code also includes requirements for specific types of equipment, such as transformers, generators, and motors. These requirements are designed to ensure the safe and reliable operation of these types of equipment. For example, transformers must be protected from overcurrent and must be properly grounded. Generators must be equipped with overspeed protection and must be synchronized with the electrical system before being connected. Motors must be protected from overload and must be properly grounded. In addition to the technical requirements, the National Electrical Code also includes requirements for administrative and enforcement procedures. These requirements are designed to ensure that electrical installations are inspected and approved by qualified inspectors. The inspection process helps to identify and correct any code violations before the electrical system is put into service. The National Electrical Code is a complex and comprehensive document, but it is essential for ensuring the safe and reliable operation of electrical systems. By understanding the requirements of the code and by following best practices, you can help to prevent electrical hazards and protect yourself and others from electrical shock.